A pair-sided die is rolled 4 times. What is the possibility that 4 rolls form a strictly increasing sequence? We need to calculate the total number of outcomes possible with 4 rolls of the die and also the number of favorable outcomes of strictly increasing sequence. Once we have calculated these two numbers a and b, we will take the ratio b by a to get the required probability. A. The outcome of the first roll can be 6, as any number from 1 to 6 can show up. The outcomes of all the other rolls will also be 6 for each roll. Therefore, the total number of outcomes possible is 6 multiplied by 6 multiplied by 6 multiplied by 6, that is 1296. This is the number A, say, and this is possible in 6 rolls. For a favorable outcome, we need a strictly increasing sequence. The word strictly increasing can be interpreted to mean an increasing sequence in which all the rolls produce distinct or different numbers, like 1, 3, 4, 6, not 1, 3, 3, 6. That is, 1, 3, 4, 6 are 4 numbers where each subsequent number is more than the previous number. That doesn't happen in 1, 3, 3, 6. We need to count how many ways we can select 4 distinct numbers from the set of numbers 1, 2, 3, 4, 5 and 6. That is, we need to calculate the permutation of 6 different numbers when 4 numbers are taken at one time. That is 6p4, that is 6 permutation 4. And by using the formula for permutation, it is factorial 6 divided by factorial of 6 minus 4, which is equal to 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 divided by 2, and that is 360. Let us take one such arrangement. Let us say 6, 4, 2, 1. These 4 numbers can be arranged amongst themselves when all 4 are taken at one time, and that is given by 4p4, or 4 multiplied by 3 multiplied by 2 multiplied by 1 is equal to 24 different ways. So 4 numbers can be taken out of 4 numbers in 24 different ways. The key point to note here is that once we select 4 distinct numbers, though there are 24 different ways we can arrange them as seen above, only one of these 24 ways will be in an increasing order. That is, if 6, 4, 2 and 1 are the 4 numbers, then only 1, 2, 4, 6 will be in increasing order. The other 24 arrangements like 1, 6, 4, 2 or 2, 4, 6, 1 or 4, 2, 1, 6, etc., etc., will not be in increasing order. So, out of every 24 arrangements, only one would qualify as a favorable outcome. So, out of 6p4, that is 360 different ways, the favorable outcomes will be in 364 divided by 24, that is 15 ways. Thus, the number of favorable outcomes is equal to 15, and that is B. Hence, the required probability P is equal to B by A, and that is 15 by 1296, that is 5 by 432. And that is the answer. We can also get the answer in another way, which is more understandable but somewhat more laborious. This method is discussed below. Before going any further, please like, subscribe, share, and hit the bell so you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Without further ado, let us proceed with the rest of the video. Okay, now let us discuss the second method. The total number of possible different results in 4 rows is 6 multiplied by 6 multiplied by 6 multiplied by 6, that is equal to 6 to the power 4, and that is 1296. Only some of these are in a strictly increasing sequence. Let us enumerate only those sequences with the following constraints. The first row can only be one of 1, 2, or 3, because if it is 4, 5, or 6, there cannot be any increasing sequence of 4 numbers. If the first row is 1 and the second row is 2, then the other two rows can be 2 of 3, 4, 5, or 6 in an increasing sequence. If the first row is 2, the other rows can only be 3, 4, 5, or 6 in an increasing sequence. If the first row is 3, the only possible rows can be 4, 5, and 6 in that order. With these considerations in mind, let's tabulate the possible distinct 4 rows for increasing sequences. We will take the first row to be 1 first, and then 2, then 3. And if the first row is 1, then there could be 2, 3, 4, 2, 3, 5, 2, 3, 6, 2, 4, 5, 2, 4, 6, 2, 5, 6. So these will be the different sequences with first row as 1 and second row as 2. If the first row is 1 and second row is 3, then there are 3 possible combinations: 1, 3, 4, 5, 1, 3, 4, 6, and 1, 3, 5, 6. And with first row as 1 and second row as 4, there is only one combination of 1, 4, 5, 6. Similarly, if the first number is 2, then there are 3 combinations with second row as 3, and those are 2, 3, 4, 5, 2, 3, 4, 6, and 2, 3, 5, 6. Finally, there is only one combination when the second row is 4 and the first row is 2, that is 2, 4, 5, 6. When the first row is 3, then there is only one possible combination, 3, 4, 5, 6. So all these combinations have been counted out in the rightmost column, and that count comes to 15. So there are only 15 combinations of increasing sequences with 4 consecutive rows. Therefore, the probability of one of these 15 sequences occurring in a total possible row of 6 to the power of 4 is 15 divided by 6 to the power of 4, or 15 divided by 12, 96, that is equal to 4 by 432. That is the answer.